Hi, I'm Tom and I talk about code. Today we're back writing more Rust. We're working on my 16-bit virtual machine. Off camera, since the last time I streamed this, while I was on a plane pretty much, I sat down and finished all of the gross macro work I was doing before. We now have a brand new instruction set, and with that, I figure it's time to actually write some tests to verify that this works how I think it does. Hopefully this is going to be a good way for me to, stretch out the new instructions I've written, and also for the people that didn't see me write these new instructions, get a grip on how they actually work. So we'll be going through arithmetic instructions, we'll be going through control flow, we'll be going through stack instructions, comparison instructions, and then if we have time, we'll be looking at how flags work, where flags are things like, if the previous instruction was a test instruction, did the comparison pass or fail, did integer arithmetic overflow, things that are useful to know but not actually really critical for a lot of stuff. Like, we can do a lot without ever worrying about this, so it's a bit of a stretch goal for this stream. But it works a little bit differently. We'll wrap around to this. For now, we're just going to be writing a bunch of tests. So not the most exciting stream, probably, but an important one. Because when I was working on this stuff, I kept running into this problem where, my code, I would try and write a test program and it just wouldn't work. And I wasn't sure if that was because of my code, of my assembler, or because the instruction wasn't implemented properly. So yeah, we're diving into tests. It turns out Rust is really good for writing tests. I have an integration tests folder, and I've started writing a couple of tests. So for example, for arithmetic, I've got a little harness. It makes a virtual machine. It runs a program that we're writing just in instructions, and we have a couple of assertions that the result is what we expect. Here, we load immediates into A and B, and then we add them together and store the result into C, and then we hold the machine. We've set this up with a halt handler that's a little bit different to the normal machine, but that's fine, because this is the only system operation we're going to actually need. We're testing the base operation of the machine here. Very low level stuff. Let me jump over so I can still see. Awesome, Mick has given me this thumbs up that I am audible on stream. This is great. I did the same thing for subtraction, and I found out that subtraction didn't work because if we jump over to the virtual machine, I hadn't found in Rust, where is it? Wrapping sub. Rust, you have to be very explicit with this stuff, but I wanted to actually wrap around when I subtracted. So we're doing that properly now. And the next cab off the rank for a test, we're going to say test. The next thing to target is going to be add test, add immediate. So rather than just, oh my god, typing and talking is hard. Rather than adding two registers together, we're going to basically copy and paste this, but do it with an immediate instead of a second register. I'm using a return result on the test here. I didn't know you could do this in Rust, but it's very intuitive and very cool. It means that we can, anywhere we have a result, this just kind of, if it's okay, the test, if it's an error that we bubble up, the test is going to fail. Very, very good, very cool. And if we return an error, the whole test is going to fail. So we are going to load an immediate into A, and let's just double check what the format for this instruction is. All this stuff gets automatically generated now. Let's move this so they live together. Excellent. Okay, so add immediate signed. Takes a register, takes a literal. Really, really simple. So let's start with a nice number. Let's say 23 in A, and then we're going to say add im. Yeah, good. I think before I was typing out the word immediate every time, and that felt a little bit stupid. So we're just going to do this. It takes a literal 7-bit. So in this case, we have to be very careful about how many bits each number is. We have these types that wrap smaller, normal fixed width types that just give us a couple of nice tools for encoding and decoding. So a literal 7-bit, let's add 4 to it. That's a nice small number. And then we'll halt, and we'll make sure that the A register is equal to 27. Okay, excellent. Now if we test, we see this is going to pass. Excellent. Excellent. So the other thing that we probably should test is what happens if we're at the top of the 16-bit range. So let's say we do this, overflow. Like, what happens if we do FFFF, right? what happens now? Does this blow up? And it panics. Expected. Is that just because the assert failed though? Where are we? It has to overflow. Failed. Expected A equals 4099. Okay. So no, it didn't overflow. 4099. FFFF 4099. That's a bit weird. That's not a number I would expect. So I don't think this is behaving any way that I would expect it to. Let's just delete that for now and we'll wrap back around. This can be part of our flags investigation when we actually track overflow and do this a little bit more properly. We have more arithmetic kind of operations. Actually, do you know what I've just realized? Because we need to do shift left and shift right. So we'll do this. Test, shift left. Do I actually need the word test in this name, by the way? Or should I just get rid of this? Is this redundant because we've already annotated as a test? Should this just be shift left? I think the most important thing is that I'm consistent, but it feels like that's maybe a good idea. Okay, so we're going to test our left shift. This one is nice and easy to test. Where are we? We have picked up a space somehow. Okay, so let's do this in register C instead, because it's good to just mix this up every now and then. Let's do a left shift by 4. Shift left. And what's our instruction format? Register, register, nibble. So we take a source register, we take a destination register, let's make this different, and we take a nibble. So in other words, just 4 bits. For how much we're going to shift. We're going to shift by 4. And then we want to say that register B should be FFO. And we'll just print these out in hex because that's going to be easier to visualize the left shift, because we expect if we shift by 4, we just pick up the bottom 4 bits as 0. That should be good. That should work. That was a weird little paste there, I think. Don't know where that came from. So we expect 0x FFO and get register B. Maybe I should write a macro that's something like assert register, and then I can just say B. I can just say this. This feels like it would have utility here. I'll think about this. I'll consider this, because that would just expand into what I have up here. That would actually be very easy to write. Very, very easy. Okay, I'll think about this. But asserting with value of register is basically the only thing I'm going to do here. Okay, another test passes, beautiful. Now we're gonna hit the meat. So shift right is harder, because when you shift right, you have to deal with 2 cases. In one case, if you have a signed number and you shift it to the right, what do you do? Do you keep 1s in the top bits, or do you get rid of them? Like, do you just fill with 0s? You have 2 options. Let me draw this real quick because it is kind of interesting. Let me just swap over. Okay, you have 2 options. Option 1, shift right. Let's say you have the number. What's a good number? Let's say hex 8FF, okay? And you shift right by 4. So, this top, well, either you end up with hex 08F, or you end up with F8F, right? Because when this top bit is 1, this is a negative number, and when you shift to the right, if you don't preserve this, you end up with just the positive number 8f, whatever this is. Let me just think about this real quick. Right, so either 143 or what's the value of a... This isn't quite right. Anyway, it is basically this, where you have it's harder. I need an extra. Hold on, I made a bad example. I need an extra digit here, and then this makes sense. Except that went to the right. 8F. Yes, sorry. You got to be really careful about your integer width here. I need the full 16 bits. Now it makes sense. So is there a way? Is there a visualizer for this somewhere? Yeah, here we go. Unsigned 16-bit. F8. FF. Cool. No, except I want it to be negative. Okay, cool. Whatever. But this problem where are you preserving the sign or are you not preserving the sign? That's ultimately what I'm getting to, just in a long-winded way. Okay, cool. So, where did my chat go? Here. What am I doing? Face here. Perfect. Flawless. So I'm going to write this and it's going to be wrong. And we'll write a test that fails and then go from there. Let's put this in A this time and let's use that number from my example. 8FFO. Let's shift A into C this time. We'll shift right again by 4 because 4 is a good number. Maybe I should do a more tricky number, but we'll just go with 4 for now. And so we expect A to be 8FF. No, sorry, we expect C to be cool. 8FF. Now, let's do the same thing, but we have to be explicit as well. So this is logical. I think this is what they're called. I think this is the difference. We'll find out in a second. I might have to turn to Google. So let's do this, except this time we expect it to be F8FF. And one of these blows up. In fact, they blow up because I made a syntax error. Okay, here we go. Test right. Expected 8FF, C equals FF. That panicked sooner than I thought. Shift right logical. Shift right by 4. Huh. We just got FF. We lost the 8. So this is clearly something I misunderstood. Shift right logical. Thank you, Stack Exchange. Okay. Yeah. So what to put as X? Logical, arithmetic, put A. Rotate, put D. That's what I said. 2's complement. So what the hell's happening here? Shift right by 4. Let's check out the actual implementation. Do I look like I'm leaning weirdly? I feel like I have to sit a bit weirdly to get around my mic. Also, I have a pop filter now. I forgot to mention that, but that's very exciting. Shift right logical. Base right shift. That should be fine. AC 8FFO. Right shift by 4. What if I just right shift by 1? What do I get? 7, 8. See, this is right. Where did the... by 2. So this should be... hold on, I can do this. This should be C... F... Oh man, this is hard. CF... Is it CF3... CF34? CFC. Oh, that was too many digits. Yeah, CF3. 3FC, sorry. 3. No, wait, hold on, but that's not right because we're shifting this to the right. CF is right, but what's the where we lose the top bit? Where does that top bit go? We're shifting right. Where does the top bit go? Right? Because as far as I'm concerned, we should... So let's look at this, right? So we have 8FF, which is 100011111111. Right shift 4. This should give us well, we... Alright, sorry, let's right shift by 2. Let's right shift by 2. So this should give us 1000 and say 0010 0011 1111. Is that what I said? That's not what I said. Why did I say C in the bottom? Because we have enough. So it should be F3 2, right? 1, 2, 3, 4, 5, 6. Because we lose 2 of these. These disappear. They're gone. 2, 3, F. So, like, right shift is not hard. This is not where I expected to get stuck here. That's weird. That's very weird. 3FC. 8FF. 3FC. What is this? Hold on. So 3FC is 00111111. This is what I said originally, though. Shift right. Shift right, as in we're going this way. We're truncating things off the lowest bit, right? 111100. So this looks like a left shift, right? What? Have I got my shifts backwards? Have I done something silly? What the hell? What is going on? What is going on? Okay. Shift to the left. This is good. Shift to the right. Yeah, we pull in from the top bit. This is what we do. Wait, what? How have I what's going on? Surely I've even... This is very odd. This is very stressful. Let's go back to the VM where we implement... Wait, hold on. Shift right logical. Okay, shift right logical. 101. AC. Yeah. Right shift. Set register R1. Oh, set.value. Yeah. Am I going crazy? This is so odd. I've got to have done something really silly here, because this works exactly like I expect it to, but this for some reason doesn't. What if I... Okay, well, let's at least do this. I like this shift by 2 actually. 2, 2, 3, F. 2, 2, 3, F. 3 FC. It's just so frustrating. Mick, my mic and camera are clean as. Thank you. This is the same microphone I've had for 10 years now. It's done well. It was a good investment. Yeah, but this webcam's newer than lots of my Quake stuff. I'm glad I got it. It's looking a lot better. I have a light as well, actually. It looks even crispier with the light. I just don't... Oh. Let's do it. Let's get the light. I had this set up. I was recording some stuff about a wooden puzzle. There we go. That looks a little bit nicer, I think. Room's good. No, this actually, it makes a difference to how the camera picks me up against the background. I think this is okay, as long as it's not too intense. Where is it? Whoa. But yeah, they get a lot of light in this room. I've got a gigantic 3-meter wide window, which is bigger than anyone needs. Okay, shift right logical. The other thing is, have I somehow matched the pattern weirdly? Right? Have I done something... I don't need to change. Shift left. Hold on. Okay. Here's the other thing. Here's the other thing that happens that I've got to check. I've got to check for overlap in the opcode. Because for a while I had some of these opcodes. Like I would have this as 6 and then just the wrong thing would would get evaluated. So, okay. Let's go back to the VM. Right? And we do actually println the instruction. Cargo test. So where does this get printed? Running shift right okay, running shift right logical AC2. So that's correct. That's correct. It runs the instruction we think it does. 3FC. Okay. Let's skip this assert for now. Let's see if we have any different luck with the arithmetic shift. Excellent. We've got a question in chat. Let me just move some things so I can actually see chat. Yes, cool. CodeAnk11, welcome. Talking about investments. Yeah, ask me a tech question. Go for it. I love to answer questions. I love to talk. Ask me anything. Okay, this is similar to what I thought. But again, this is 8FF. This isn't even... Right shift. This is fine. Oh, CodeAnk11, do I have any keyboard recommendations for key rollover? They're all pretty good these days. I have bought really cheap, like AliExpress keyboards in my poor uni student years. You know, even going back to 2016, like key rollover, I don't find is a thing anymore. I've done a lot of gaming with a $40 MX Brown knockoff keyboard that I bought. I think literally in 2016 or 2017. It's traveled with me to a bunch of places. It's fine. If your keyboard is from 2010, then you might have rollover problems, but I think even the cheapest keyboards don't struggle with rollover like they used to anymore. But if you want a good keyboard, I mean, like, what do you mean make your bank cry? Because there's just so many good options these days. It's hard to even know where to start. I really want to build a gaming keyboard that is in this form factor, this 40% ortholinear. I think they're really cool. I think they travel really well. I usually game brand name. Last year we both get stuck non-keys. Brand name. I mean, like for general typing and work, lots of people have a lot of good luck with the keycrons. I've used them. Well, I've used them on other people's desks and stuff at work. They're solid. They're built like a brick. They'll last you a while. The keyboard I use for gaming mostly is a SteelSeries from 2013, I think, and I love it, but I don't know if the new keyboards hold up to that. The 6G V2 and the 7G, I think, are just like top tier keyboards. Otherwise, yeah, the keyboard I used, there was a cheap Chinese brand, Royal Kludge, served me really well. If you want to go for cheap shit and potentially, you know, have to deal with it getting held up in customs and stuff, Royal Kludge. That's the brand that served me. Okay. So I'm trying to think about what's going on here, right? Because this is a right shift. This is a right shift. I don't think you can buy a SteelSeries G7 anymore, by the way, not for the last 10 years. That was just coming off the top of my head, but more just that I've had luck with SteelSeries keyboards in the past. Oh, hold on, I'm meant to be on a different scene for this, aren't I? Okay, so. Oh, that's the end. That's the end of my page. We've got another right shift. Okay. So this time we right shift 8FFO and we're getting FF. And this is better because this is almost a right shift. We're just losing this bit somehow. Like, this should just be 8FF. Where does the 8 go? So one thing that comes to mind is that maybe I'm missing something about how Rust does shifts, and it's worth checking the Rust docs. What it says are arithmetic right shifts. Okay, so we have a right shift. Transition all order types with multiple right hand side types. Handling for blah blah blah. Okay, so sure. Excellent. 5 right shift 1 is 2, yes. Well, let's test this, right? These are the canonical Rust examples of what this shift should be. So let's load 5 and shift it right to the 1 and assert that it is in fact 2. Okay, good. So this is actually a brain problem. This is a me problem. Because something... How have I done this so badly? So if I shift this right 2, though, I would expect it to be 1. That's okay. What if I... Okay, let's pick a smaller number. Let's pick FC, and then we should get 3F. I'm really eyeballing this. Okay, so for some reason the numbers I picked were just a bit bad, and maybe this is a... hold on. Is this possibly because... Like, what type do we get? Because this is an 8-bit number and this is a 16-bit number. So what if I do my old faithful and wrap it in an as U16? This is important, right? So let's go back. What if I change my numbers back now? Two 3F, 3FC. Okay, no, that still doesn't work. Let's go back to the thing that works, and we'll investigate this more later. Okay, that's weird. That's weird. What if I add a 1 here, right? And so rather than 3, the 1 drops in, and it should become 7, right? Or does it break as soon as we... No? Okay, this is obviously just brain. Camel cased Rust. Where's my camel case? What have I done? What have I done? Where's my camel? These are underscores. Mad Flash. Fight me. Where's my camel case? Unless you mean my I thought enum names were meant to be camel case, Pascal case. Is this not the style? am I gonna get kicked out of Rust school? I've been very good with all my functions. It's an enum. It's an enum. Oh, I see what you mean. It looks like a function, but that is an enum. I just included... I didn't want to type instruction 58 million times for all of these, so yes. Okay, so we need a bigger example here. Let's go FO, right shift it by 2, and then we expect it to be FO, right? No, sorry, we expect it to be FC. I'm gonna write this macro. This is annoying me. I'm gonna do it in a second. I'm gonna write this macro, and this is gonna fail. This is gonna fail because there are 2 bits missing, and that's good. Okay, so now we're gonna go in. We're gonna look for well, let's look at U16. Sure. assign arithmetic sure checked sure. This is to do with overflowing sure shift. Let's maybe search for shift, arithmetic shift. Mad Flash, am I a game dev? No, but I have made games. If you want to be silly with semantics. I would like to make some games. I've played with Bevy a little bit. Bevy's cool. Oh, arithmetic right shift on signed integer types. What do I work as? Yeah, no, I'm an enterprise backend developer usually, but right now I am unemployed and enjoying it. Just taking some time, learning a new language, playing a lot of music, having fun. So yeah, you can tell I'm not a web dev. I've worked with some good web devs, okay? I've worked with some good web devs. Now, we're gonna do this silly thing because I can't think of a better way to do this, but we're gonna memtrans we're gonna reinterpret the register as a signed 16-bit number. It's just is it std memtransmute? Or is it just memtransmute? Let's do this for now and then see if Rust yells at me. Actually, am I already? Yeah. Okay, there it is. So we get a signed number, then we right shift it by offset value. I don't think we actually need this as 16 thing. And now if we test, oh, oops, I forgot to transmute it back. Okay, still doesn't work. But is that just because I didn't do the right thing? No. Shift right arithmetic. Shift right arithmetic. FC. So this looks correct. Okay, we're doing the right thing with the bits. We're doing the right thing with the bits. I'll jump back into this as U16 just to make sure that no weird int type nonsense is happening. And let me just do it like this as a... let me be as explicit as I can about what I expect the types to be here. Okay, let's try this. That is good. I was writing with a go. It really rots the brain. FC C equals 3C. So we've still lost these 2 bits. This is a signed number. It just is. Base A. FO is a signed number. Oh no, it isn't. It isn't, because it's a 16-bit number. We've got to do FFFO. Sorry. That's very silly. You can't just you can't just expect it to extend everything out. Okay. So this is good. FFFO. If we right shift that by 2, this is going to be the same, but we just expect it to pick up extra Fs. So that was actually correct. I love it when my test is correct and I am wrong. FFFC, C equals 3FC. So this is the same kind of thing, right? 3FC. How does this happen? How do we get here? Okay, so 3FC is 0 0 0 0 0 0 1 1 1 1 1 1 1 1 0 0. How did we get here from 1 1 111111111111000, right? What operation gets us here? If we left shift by 2, that's kind of like what one operation gets us from here to here, from here to here, right? What is this? This is like, so if we, let's just draw a line under this now. So this number, right shift 2 equals 0. Well, let's say xx111111111100, right? This is what it should be, where xx is either 0, 0 or 1, 1. But that's not what we see here at all. In fact, what we see here is this number. So this star equals this. It's, how do I do an and? It's this and 111, yeah, it's this and 3fc, right? It's the, I guess you could also exclusive OR with these bits, but what I'm kind of getting at is, like, this mask just doesn't make sense to me. This just does not make sense. I don't understand where these bits go. I understand if these 2 bits are 0 and then these 4 are 1s, that's fine. But we are literally just losing a freaking byte here, okay? And that's not good. That's not cool. So this is why you write tests. Imagine if I'd written a compiler, okay? Imagine if I'd written a compiler for this language, and then I was trying to run code and I was getting unexpected results, and it was because right shift wasn't working properly. Like, how would I know? Is the problem in my compiler? Is it in my assembler? Is it, you know, you've got all these layers where things go wrong, and it's really, really hard to know if your instructions are broken. Oh my god, I'm spilling my tea. Okay. Shift right arithmetic. I really just gotta hunker in and focus on this. What has happened? Omega A. Shift right arithmetic. A 4080. 4080. 4080. FFO. Oh, yes. Yes, yes, yes. Haha. Ha ha ha, yes. Ah, I see what has happened. I see what has happened. Oh my god. Okay, so the immediate instruction, and I kind of, this was going in the back of my head, right? The immediate instruction, damn. The immediate instruction does not support a full 16-bit number. This is the only one. Every other type that has a fixed size bit field, I've not done this with. So I guess this is a sign to do make U16 more restrictive, right? A type that actually verifies, or that, you know, maybe warns us if we try and make something too big. I don't know. Some way so we don't just do this. Like, when you make a literal 7-bit, you know that this has to be a 7-bit literal. If instead of here I had to say literal 12-bit, then I would look at this and be like, hold on, this is more than 12 bits. So this is what's going on here, right? This is only a 12-bit number, but I'm trying to put the top 4 bits in. So I actually cannot set these top 4 bits. So how do I do this? Well, I have to, and for one thing, okay, here's a fun thought. Here's a very fun thought. I could shift left right? I could shift it left by 4. And then I could add something into the bottom. I can't add this because that's too big for the type. What's the biggest 7-bit number? Or I guess so I guess it's just 70, right? Because that's 1, 2, 3, 4, 5, 6, 7. So this gives us A equals hex FF70. Now when we shift right by 2, we should get this same thing, but with a gap. So it'll be, instead of 1, 1... No, it's, hold on, where does, so the gap is there, so this is gonna, well, let me just run it and see, right? Let me just run it and see. FFDC, that's correct. You know it when you see it. It's hard to work out in your head, but that 0 is in the right place. That 0 has shifted 2 places. Yeah, because you end up with 1101, which is D. Excellent. Excellent. Okay. That's really good to know. That's really good to know. We should do the same thing here. We should definitely do the same thing here. Let's put an 8 in the top bit. Let's shift A left by 4 bits. Let's add an immediate. Let's do 7.0. Let's do 7.0. So A equals 8 FC7. Now we shift right. Logical, what we expect is... okay, let me do this one on paper because this one's a bit harder. Let me do this one on paper. Oh my gosh, I need another page. Okay, so what did I say? 8FC7. This is 1000111111000111. We're shifting that to the right by, let's do 3 bits. Let's change this to a 3. That's a nice juicy number for a right shift. So then we would expect it to be 000111110001000, where our nibbles are collected like this. So that would be 8F11. Except that was backwards. 1F88. No, sorry. 11F8. Does that make sense? It does. It does make sense because all 3 bits of this 7. Sorry. I gotta shift. We gotta do this. Looking at screen with one eye. Looking at screen with one eye. Yeah. Cool. Okay. Excellent, and that works. So now that I've worked out that the immediate instruction needs some attention, that's a lot better. That's a lot better. Let's write a fun macro. Let's write a... let's look at the Rust docs for it, because I have to check every time. What are they called? Macro rules. Okay, so let's call it assert reg. Let's call it assert reg. It's gonna take, what is it gonna take? It's gonna take it's gonna take, and it's gonna take, let's call it R, and it's gonna take a value. Oh, oops, that's, so we're gonna take, I think like this. Let's find out. We're just gonna write it and we'll find out. And it's gonna turn into assert. VM get register R V expected V R VM get register R. Okay, let's unused macro. VM C the virtual machine, the name of the register, and the value. Excellent. That looks good. That looks really good. Let's just make sure that it can actually break. Perfect. Okay, so we now have a much better way of testing registers. And I love when you can just write a quick macro like this. 11F8. Isn't that so much cleaner? Isn't that so much nicer? Beautiful. Okay, let's do the same thing here for register B and FFO. Colt Zero, hi, how's it going? Welcome. I'm surprised as many people have stopped to look in as they have, because this is a really weird time of day. I fully appreciate that many parts of the world, I guess, are like asleep, maybe, at this time of day. Okay, awesome. So this is some good arithmetic testing. Now I have realized in all of this that I may be missing a few instructions. Missing a couple of instructions, okay? Because I have left, I have shift right. What about logical AND? What about logical OR? What about logical EXOR? These are all important. What about bitwise negation as well? I guess you can probably implement that in terms of the others, but that would probably be useful. So maybe we'll come around to that in a second. Let's let's put a to do and or XOR not. Cool. Load and store we will ignore for now. Let's do jump tests. Well, let's do jump and let's do jump and add if, I guess. Madflash19 says, why write this in Rust? Because it's fun. Because I like Rust. Rust is cool. And I want to learn the language. I've never written Rust before, really. You can do cool things like this. Like this whole instruction set, all of the encodings and decodings are generated by this gigantic 150, 200, 300, 400 line block of macro madness. And it's kind of awesome. So if I want to implement a new instruction, let me show you as an example, right? So we've got to give it an opcode that is not yet taken. Let's take, we have 5 bits to do this. So let's do 10. Let's do the next one. So opcode, let's just call it AND. We take a register, and we take a register. What have I done here? This needs a close bracket. Excellent. So this instruction, if I were to build this right now, would have encodings and decodings and string and from string instances all generated automatically by the macro. Odin? What do you mean Odin? Odin? What's Odin? I don't know what Odin means in this tape. But yeah, Rust takes time. It really does. And that's why I just want to mess around on stream with it, because it's fun. Odin Lang. Nah, I'm trying to not branch into too obscure of a language, right? If I had to, I would like to learn Haskell and do, like, maybe make a game in Haskell. That's something I would love to do one day. Have I heard about the RCE cheating scandal? No. RCE. So, like in Counter-Strike or whatever, people are finding ways to just execute their own code in the server. That's kind of awesome, but also horrifying for people that, want to play competitive games. Um, that's wild. But yeah, you know, some of these servers, especially anything, you know, anything that's ultimately based on Quake, right? It's a very flexible engine, and it was written a very long time ago. And a lot of people understand the inner workings of these engines to some degree. You know, like they all have this shared lineage. I don't know how much is really the same. Source 2 is probably completely different at this point, right? But I don't know. It's interesting that if there's a way to remote execute code on something, someone's gonna find it. Someone's gonna abuse it. Mm. Cold Zero says Blender has a feature where you can make a bounding volume hierarchy, but Blender doesn't give you access to the internal data. Hmm. Bounding volume hierarchy. What is a bounding volume hierarchy in this context? Okay. I've been going very slowly. I got really blindsided by that annoying issue. So let's check something off my list. Let's do it. Let's go here. Let's go back to the first page. We're gonna check off arithmetic. We're gonna do it. It's kind of done. I need to add more instructions, but let's check it off. And now let's do some control flow. So if I look at arithmetic as my golden example, I probably should actually tests. Can I go common.rs? Is that okay? Is this fine? Is this serviceable? Let me actually pull this up. Rust integration test shared code. There is a good example of this in the Rust book. Integration testing. So they put it in its own mod. Important using it within tests. This is so yeah, okay. I'm going to ignore this. If you make it if you just put this common file here rather than in test/common/mod.rs, the test runner will look at it as if it was a test file, but that's fine. I don't care about that. Let's make these pub because they're their own crate, apparently. Let's make this a pub const, and then I want to make this a, I think, macro export. Is that what it said? Macro export, yes, cool. Okay, so run not found in the scope. Run not found in the scope. Run. Oh, mod common. Of course. And then this is good too because we need to do these includes again. And because this is kind of like the foundational one, SP. Yeah, okay, so I don't need these, but I do need that. Excellent. Okay, fantastic, fantastic. So now if we go tests, flow, I can just say mod common, use common. And let's copy these as well, because I don't want to be writing out the word register and instruction 58 million times. Okay, so let's write a control flow test. Let's write one where we say function test jump. Nothing too crazy here. We want to jump the PC. We just, the program counter, let's do it. Now, the more I look at this as well, the more I would love to have maybe a macro like this where I could say run maybe have, you know, this list of things. But then maybe also have like a block of code that ran before the machine, if that made sense. So I could kind of say like, you know, I could do a few things before it took off, maybe. But there's really no reason for me to actually even initialize the machine here. Okay, I'm gonna do it. I'm gonna do it. I'm gonna make an improvement to my harness. I'm gonna do it right now. This is ill-advised. Macro export. So this is gonna take, it's gonna take a thing. It's gonna take a thing. That thing is gonna be in the program even. And it's gonna be a expression. And we're gonna give back I don't know, I probably don't need this right now. I'm gonna do this the cheap and nasty way. No, we won't. Okay, we'll do this the cheap and nasty way. What are the other things that I can have? Can I take like a body, a block? Okay, Rust macro rules. Show me the full DSL for this. This is a bit of a sidetrack. Not the doc. I want the actual Go doc. Rust doc, sorry. Go doc. Wrong word. Doc.rs. Not this. Show me the actual macro rules attribute. No. I want. Hold on. I want std. It's part of the standard library. How do I get to the standard library? Here it is. Okay, you can just do that. That's great. Now I want to find it. Where does this come from? Is it part of the compiler? Am I being silly? Block. Okay, I think block is actually just what I want. Okay, so after the machine gets reset, before the program, I want to drop pre. And then I just want to run program with the VM and with the program. And we want to wrap it up like this so that the thing that drops out we can put a question mark on, I believe. I believe that's how this is going to work. Alright, so let's do this the other way too, so that this doesn't actually break our old tests. We'll call it run 'em. Flow. Okay. Unexpected end of macro invocation. Flow 17. block. What is a block? Expression. A block expression. Yeah. Inner attribute statements. I thought that would work. Okay, let's just get rid of it because I don't think we actually use it anyway yet. But we're going to keep this as a macro because one day we might want to extend it to do a few more things. Okay. Hold on. Nah, this... Because the assertions have to... I could be much more clever with this, but actually... I'm just gonna delete it. I forgot the assertions were weird. Again, you could wrap it all up inside this kind of macro. You could write a little DSL or something that did it in a very smart way, but I want to avoid being smart if I can. Even if it means dumb VM setup. But I think run should probably reset. Oh no, but yeah, every time you call run, it's going to reset the machine. Okay, this is it. This is it. This is what we do. Okay, beautiful. Beautiful. Just to make it a little bit smaller. So if we want to test jumping the program counter, we should just do this. We should say... Actually, this is hard because it's going to jump and then it's going to blow up. It's going to blow up because there's not going to be anything there. So let's maybe say jump... and I think it's a... Is this right? Literal 10-bit. Let's jump to instruction 10. Oh, jump that set the PC to 10, which means that then we'll need to put not instruction in. So 0, 1, 2, 3. So 0, 2, 4, 6, 8, 10. So this should work, I think. And we'll assert the register VM. We'll assert that the program counter is equal to 12. And then this needs to be okay. Helps if you close your delimiters. Use common exert reg. Okay, I have known opcode 0. Oh, of course. So this means that we've jumped into no man's land. Okay, and this is good. We have a really solid check. And this is really... one of the things that I've decided with this is that there's no opcode 0, right? So if you somehow jump the PC to somewhere unexpected, if that memory is zeroed, it will just die. So that's great for this kind of test. I think what this means is I'm just one instruct... Whoa, where did that come from? One instruction sort. What did we get? Yes. Okay, good. So this actually should be 14. Cool. Everything passed? 0 failed? Looks good. So this is interesting because 0, 0, 1, 2. So 0, 2, 4, 6, 8, 10, 12. Oh. See, this is hard because as soon as an instruction is read, if we look at where our VM, if we look at where we load an instruction, right? Whoa, I'm pasting that again by mistake. Get register program counter, and then we add 2 to the program counter straight away. What we probably need to do. So we probably need to do this last, and we probably need to only do this if we haven't modified the program counter. So let's make a boolean that's going to be called did jump PC. Hold on. This is actually a great candidate for flags, right? We've got a flag. Let's say set register self if R is register P. If we set the program counter to something, then we set the flag. Can we do that? Does that make sense? And then we clear that at the start of every... Is this a good use of flag? Maybe. Let's do it for now. Let's do it this way for now. Does Rust support binary literals? Didn't I do this the other day? Didn't I ask this? 0B. You can do it. Okay. Cool. Set flag. All we do is set flag did jump true. Cool. So the last thing we do here, down at the bottom, at the other end of this, if self dot get flag did jump. If we did not jump, then we want to set the register. We want to we want to manually set it, but then also immediately unset the flag. This is janky. This is quite janky. The interesting thing is, I don't know if this actually has any practical purpose. I don't know if this is a good way to do it. This might actually be better served as a thing, but we'll try it for now. And let's also say self.set. And you might be looking at this and thinking, well, this is never going to be meaningfully read by any other part of the system, but you don't know that necessarily, because in between instructions, there might be other things that interact with the system, with memory. You know, the end of a step might trigger another component of the system running. There will be other things interacting with memory and potentially with our registers. So it's not always that simple. Have I written a compiler before? Yes, I did the whole NAND to Tetris book. So part of that, actually, was it a compiler? Kind of. There was a whole like virtual machine. I've translated things from higher level languages into lower level things before with code. If you would call them compilers or not, maybe up for debate. I have played around in the past with writing a Lisp compiler, and I would love to pick that up on stream and port the Python code logic I had into Rust. I think that'd be a fun Rust logic. Have I seen Jai? I have seen Jai. Jai is secretive, so I'm not very interested in the ecosystem. But it's cool. It's a cool idea. You know, Jonathan Blow, more power. It's Jonathan Blow, right? I'm not crazy. Jonathan Blow, yeah, excellent, good. I read the whole Elements in Computing. Yeah, I read that book pretty much head to toe. I didn't do all of the programs. I don't think I wrote all of the programs for the virtual machine that they talk about, but I really loved that book, especially the low-level stuff. I, poured over every detail of. Okay, so now we know if we jumped. No, we don't, because we haven't actually... Oh, no, we do. If anything set the program counter, then we know we jumped. So let's try this. Now we should be able to go back to our flow, and we should be able to remove this, and it should work. And of course there's something wrong here. Yes. Wonderful. Actually, what if I do this, right? Set flag, get flag. Did I get rid of test flag? Sorry. Okay, that's looking better. Unused result that must be used. Except, I don't know if this has to have a result that must be used, because what if I just do this? No. Okay, it's there's a couple of things where I'm relying on this. Cool. That's good. That works. These pass. Jump panicked. Expected E, yes. Oh, perfect. This is good. This is exactly what we want, because this should now be 12. Mad Flash, why do I work as a back-end dev? Because that's where money is. I don't know. I have followed the path that my career has led me. I haven't really had a clear idea of what I wanted from it. And ultimately, this was my backup plan. I tried to be a musician, it didn't work out. And so now I'm just smashing code and making money wherever it comes up. I worked at a bank for a while. It's not... Like I have projects like this that I'm very passionate about, but honestly, the day-to-day stuff, it's just mostly paying bills. And I take pride in it, and I make sure I do a good job, right? But it's not like, I know this thing, or I know this thing, I have to use this, I have to achieve that, whatever. You just do what you do. Chad, thank you. I'll take it. I'm a bit of a programming Chad. Excellent. Okay, so that's good. So as I'm writing these tests, we're really shaking out a couple of corners and having to think about really what some of these instructions are doing, because I'd done this before, right? I'd seen this before in some code that I'd written to run this machine, and I hadn't really twigged as to why. So when you write these tests, it really makes you confront all of your demons in the code base. Now, there's a funny thing that I have been thinking about in the back of my head this whole time, and that is that I can rewrite this same test. I can rewrite this same test like this, and it'll still pass. It works exactly the same way. So actually, we've got a redundant instruction, and we're just going to get rid of it. VM, where are we? It was called jump, right? All jump does is set the program counter. Oh no, it adds. Sorry. But what's the difference with that and add immediate? It's bigger. Okay, no, sorry. We're going to keep it. And the reason we're going to keep it... So that's not... I guess that's a jump. What's the... It's hard. It's really hard naming these things, right? In one sense, it is a jump, but it's a jump by an offset. Maybe it should be jump offset or jump... Let's call it jump offset. Mad Flash, this is a good question. Where are we? Do I mention these projects in interviews? Sometimes. I've been in interviews where people have been really interested to talk about things I do in my spare time. Sometimes I'll mention that I've done a bit of PlayStation 2 homebrew, and they have a million questions and it derails the whole interview. But on the whole, interviewers like to hear that you're passionate and that you do stuff and that, you care. But they also have their own questions about their own things that they want to know. So it's a mix, right? It's good. It's good to talk about stuff. It's good to have stuff to talk about. And, you know, if you come into an interview, if I was interviewing you and you told me you were writing a virtual machine in Rust, that's a great jumping off point for me to say, well, you know, is it a register machine or a stack machine? To say, you know, how does it work? What is it, a RISC instruction set? Is it a complicated instruction set? I can ask you a lot of questions, and, you know, on your terms, kind of get you to explain things that you know about and care about. Is this spam? This is spam. Why are you sharing this? Who is this person? This is spam. This is not a tech person. I'm gonna just quietly remove this person. If I can remember how to do that. I don't think they can message anymore. I think they're gone. I won't delete the messages. I'll do that in a minute. I can't remember. For some reason, the chat pop out. I can't do this. I have to like go into a different UI for it. Maybe that's just because I'm dumb. I thought I could do it. Anyway, that's cool. I can just say they're suspicious. Cool. So jump offset. Is this still? Yeah, I missed something, didn't I? I haven't banned them, I've just restricted their access, which is, I assume, the same as a ban, but we'll see. Jump offset. Okay, so. This is an absolute jump. We set the program counter to something. Let's go test. This is going to be similar, but instead of setting the program counter to something absolute, we're going to space it out a little first and then add 10. So this should be the same, but obviously we're not jumping to instruction 10 anymore, we're jumping by 10 instructions. And so in this case, we would expect it to be 2, 4, 6 higher, so this should be 18. Perfect, still works. Now, the offset's interesting as well because I probably want this to be signed rather than... Oh dear, I probably want this to be signed rather than just an unsigned number, right? Because I want to be able to jump backwards. I don't want to just have to jump forwards. That's kind of silly. And I should be able to encode that. But converting back and forward... limited width numbers. You have to make decisions about it. Anyway. Do I get asked leak code in interviews? I've never been asked for leak code specifically, I don't think. But I have had to do coding tests in interviews. I like getting people to write stuff on whiteboards and, you know, like, it doesn't have to be leak code. I like making people write code in interviews, but leak code itself, you know, yeah, it can be a bit restrictive. But that kind of thing. Practice leak code. Just be able to talk about the problem, right? You don't have to be a leak code nerd. You don't have to get the right answer. I just want to hear how you talk about it. I just want to hear how you think about it. What's my other? I have another jump instruction. The other jump instruction is add if. So let's test branch. And this is another one where I think I only go forward right now. But I want to be able to go backwards too. I can probably make this much smaller for memory as well. This probably thrashes a little more than it needs to. Okay. So we're gonna load A as 12, B as 13, and then we're gonna test. We're gonna test A, B, test op. Are not equal. So if A is not equal to B, add if this is true. And then we're going to add to the program counter. To the program counter, we're going to add a nibble. We're going to add 4. We're going to jump 4 instructions. One, two, three, 4. This should be fine. Maybe I should actually have a way of putting invalid instructions in. Maybe I need to go... Maybe I need to go... Oops. Sorry, I just put my keyboard into flash mode. I need to replug it. Wonderful. Hold on. I was in Dvorak, I think. Invalid instruction, which we should just be able to put in here. Oh crap. This actually broke. Let's just do this. Let's just give it a dud parameter. And then it's going to complain that it isn't matched. It's just going to give an error. Cool. Okay, now this is also going to be different. We expect the program counter to be... Well, we don't actually care, right? We don't need to assert anything. As long as this runs safely, we're fine. Similarly here, we should replace these... Cool. I should have just done that globally. Oh, so this actually wasn't behaving properly, right? This wasn't jumping... Oh, no, I got a little overzealous, didn't I? A little overzealous. Okay, this is still behaving badly because we're not jumping far enough. 1, 2, 3, 4. Should this be 8 instead? No. Should this be 12 instead? No. Oh, hold on. Okay, here we go. Jump offset, unexpected. Oh, because of course we don't need to specify the PC here. Okay, that's fine. I was still just setting the program counter rather than stepping it, so that makes sense. So this is good actually. It's good to be able to put these in our code to make sure that it blows up as we expect. Cool. And we can also verify that we branch. We branch if this condition is true. Now, doing this should unset the flag as well. So let's do another test here. Let's do another test, which is going to do the same kind of thing. Except we're going to try and chain 2 branches together and see if it works. So we'll jump less far. So 1, 2, 1, 2, 3. Yeah, one. Sorry, no. Let's go 3. We can jump up to 16. We can branch up to 16 instructions this way. So this can be a kind of spring to then call out into a jump offset, or to just set the program counter to something else. That's fine. We can also set it to a register, by the way, and we will test that as well. But it's not meaningfully different than testing the add instruction. The add instruction is our jump to register instruction, which is quite fun. Now, the other thing that we maybe don't have is a JSR, is a jump and store. And that might be important. Jump and store. Ooh, jump and store is good, isn't it? Okay, that might be an important instruction to have. But what would that be? What would that be? Anyway, that's something for me to tick over in the back of my mind for a bit. Let's say add if PC nibble new. We'll just jump out into no man's land. This should just be okay. This should just fall through to this. It shouldn't add anything to the program counter, but it will in fact blow up, right? And it blows up because the program counter ends up way, we expect it should just jump up to here, but instead we're going to jump way out, way down here somewhere in no man's land. Okay, that's good. That is good. Cool. Okay, so to fix this, we need to look at our virtual machine. We need to find where the add if. This is the only other place we're testing the flag. If that's true, false. We want to unset the flag. Now when we run it, it passes with flying colors. Wonderful, wonderful. Now, yeah, testing a function calling convention is a little bit beyond what we have right now. I hadn't thought about JSR. How does, or jump and link, right? Like jumping in such a way that you know where you came from. Kind of important. What would that look like? If we look at the instructions we have right now. So this is like saying, it's like saying add and store. Because again, I would like to keep this generalized if I can. Add immediate and store. There's no room for another, unless we add a nibble. Which we could do, add im store. But there's no real point in doing that. Maybe jump offset only takes... I like the idea of being able to jump by a 10-bit number. Maybe you just have to load it and then add it. So this becomes 2, but then you get... 7 bits. Wait, what's the biggest number you can store in 7 bits? It's 64. It's 128. So 128 is not meaningful enough. You can't jump anywhere meaningful with that. I'm gonna ponder this while I go to the bathroom. I'll be back in a sec. Okay, I had some thoughts. I've been doing a lot of reflection. I've been doing a lot of thinking. Okay. Um, this instruction doesn't really do much, right? There's not a whole load of utility in jumping by at most 1024, or if we do it signed, 500 bytes in either direction. That's just not that much code, right? That's only 200 instructions. The canonical way of moving the program counter around is either going to be setting it to a 12-bit number directly, which still isn't a whole load of range, or setting it with the add instruction, right? Either set the program counter to the program counter plus another register, which lets you add a whole 16-bit offset to it, or set the program counter to like you would maybe say, A0 program counter. So add A and 0 and store the result in the program counter. That is a more effective way of loading something most of the time, because you just get the full 65,000 whatever byte range rather than being limited to 4096. That's actually not a very big number. It really is not a very big number at all. This is a very limited program counter, especially given that memory is a full 32 bits. It's kind of interesting. Might have to think about that. Anyway, I don't mind programs being a bit restricted. Like, maybe programs have to go in your 0 page, and that's just how it is. Maybe we just accept that. So out of 65,000, I guess jumping 200, it's a more significant proportion. Anyway, we'll see. We'll let that cook in the back of the brain. So I suspect this instruction is going to go away, or just basically never be used. But the thing we then need to support a cooling convention is going to be opcode. Let's go 10. Did I already use 10? I did, but I deleted it. Okay, let's say 10. Let's call it add and save, right? So this is going to take a register. This is going to take a register, and this is going to take a register. Except the semantics are different to add. This is going to be, what is it going to be? It's going to be R0 equals R0 plus R1. Let's say R2 equals R0. So this is our jump and link, right? This lets us save the program counter and then add some 16-bit number to it. And then we'll have, let's do this. Let's have the add version as well. We can have both. We have room. We've got 5 bits for we can have 32 instructions. Okay. Like we're not even close to using all our instructions yet. And I'm loving the macro stuff I've set up, because this all just has all of the code that I want generated straight away. So this is, let's just add it to our thing. So we'll say set and save A, B, C, and we'll have set, add and save using the program counter B, C. So this is like saying add B to the program counter, but before you do that, store the program counter in C. So that if we're calling a function, you would say add and save, and then at the start of that function, register C would have the return address. You could push that to the stack, do your function, pop it off from the stack, and then jump back there. Beautiful. This is the risk boy in me doing this. Okay, so let's go test, jump, and let's call the test jump and link. We're not fooling anyone. Risk 5 association, don't sue me for stealing your name, jump and link. I assume this was a MIPS thing before anyway. I'm pretty sure it is, just from looking at like PS2 disassemblies. Okay, so what do we want to test? We want to test that we can jump and then we can jump back. Well, no, we don't even need to jump back. We can just say set and save PC B, C. Let's load an immediate first. Let's go in. NA 94765787 has a random and funny question for me. Please fire away. I'm I'm nervous, but please fire away. Cool. Actually, that's not what I want. So 0 to, I want to set the PC to 4 and then save it in C. And then we... Nah, I'm not answering that. Dear. What am I doing? Moderation actions. What am I doing? Ah, that's fine. Cool. Excellent. Let's assert that the program, the C register, sorry, is 2, because that's what it should be if set and save works correctly. We'll do the same thing here. We're gonna jump by an offset this time, so let's maybe jump by 8, add and save. PC, let's do this in the A register this time, I guess. A, and let's store it in B, just for something different, mix it up. Okay, so add 8 to the program counter. So 1, 2, 3, so 0, 0, 2, 4, 6, and then this should be kill instruction, and then we again expect the B register now to be 2 because that's where add and save was called from, and we didn't actually implement them. Excellent. We didn't actually implement anything here. That's really, really good. Okay, so jump offset. We'll put it just after here. Instruction, set and save. Awesome, so we save the value in R0, and then we set R0 to R1. Add and save is going to be the same thing, we just... Cool. And then we just need to sign off with OK because that's what we're doing. We're living in result land. Unreachable pattern, 211, set and save. That's because it needs to be add and save because I made that same copy and paste error again. And then this needs to return an OK as well, and this should work. Make T. Perfect. Okay, excellent. Works exactly how I thought. First time, every time. This is the dream. This is the dream. What is going on in my phone here? Okay. I love it. I love it. Test jump and link. So this is enough for us to do function calling, which is great. I think this is fairly well tested. What else do we need to do? How do we jump backwards? How do we jump backwards? We just subtract. We just subtract. That's fine. I'm gonna tick it. I'm gonna do it. Try and stop me. Hold on, let me get the better scene up for this. Try and stop me. I'm gonna mark it ticked. Okay, let's do a couple of stack ones and then we'll call it there, and I'll finish this off and make it better off camera. But the stack ones are gonna be fun as well because I have hilariously not tested anything. You know, I have no idea how this is gonna work. So let's go test push. Let's do the old copy and paste. Okay, so we've got a new machine. We're gonna start by, now we need to load things into registers. So let's say im a 123. Now let's say stack a now. ASP. So the way the stack instructions work is there's one stack instruction, but one of its arguments is a 16-bit operation. In this case, it's going to be a push, which means... Oh, the other thing, sorry. There's two important things here about stack, and this is actually not super obvious. At the stack instruction, it takes two registers and a stack operation. This is something like push, pop, swap, rotate, duplicate, whatever. But the first register it takes is the thing you're working with. This is the register to treat as the stack pointer. In the future, I might not call this stack pointer. You could just pick a register and use it as a stack pointer, right? That's kind of cool. So you can do these in other places. There was room in the instruction for this. I could either put like a 3-bit number here or just let you set... set the stack pointer. So this will have interesting uses for fun optimizations if you want to be super nerdy about how these work. But having the stack pointer not something that the machine knows, but something that's a convention, I think is really interesting, and I tend to, like working in systems like that, especially when there's hardware support for a stack, but not at any fixed place. Or not at a fixed register. I don't know, that just feels like there's cool optimizations that people will make around this. Me, other people, I don't know. I don't know if I'm smart enough to really make use of this, but I thought it was cool and I thought it was interesting. So now we're gonna need a different assert. Now we want to assert is at memory address vm.getRegister. So the stack pointer. The stack pointer +2 the stack pointer -2, and we want it to be 1, 2, 3. Okay, so we're gonna have to go into common. We're gonna have to write a new macro rule, but it's gonna look very similar. Expression adder value. Read to. Let's just pollute the namespace a little. Expected exert result equals v, expected v got I'm gonna come around to this good question in chat in a second. At address got result. Excellent. Okay, and then this is assert mem. Okay, this doesn't quite work. Genuine question from Dinkelman. how do I write these oddly specific things with such incredible confidence while claiming that I don't know what I'm doing? Even with years of experience, your brain can't wrap the idea of doing this without LSP, whatever, no less. You just do it a lot. I don't know. I've been writing code with basically no Rails for a long time. I started doing it when I was in uni. I got sick of IDEs because they were bulky and hard to use, especially on Windows. And I was like, screw it. How much can I write just in Notepad++ with no support at all? And you get kind of good at it. You get kind of used to it. And it's really nice for a stream, I think, because I get to talk through things without an IDE like fighting me for it. When I'm writing code in my day job, I do use IDEs and you know, I have actual support on what I'm doing. But with a personal project where there's no deadline, yeah, I like to just mess around and do it kind of bareback. Honestly, you just start, you know, you just start and you just go. And either it goes badly or it goes well, and the more weird projects you start, the better they start going eventually. Like, I've got a lot of non-starters. I don't stream them. Usually by the time I stream something, I've thought about it for a little while, and I've maybe done like a little exploratory thing off stream, like cheated it just a little bit. You know, I've poked the idea a little. Maybe I've done like a mock-up in Python or something. Some of the things I've streamed, they're things that I've started working on a plane. So like, I started a virtual machine on a plane, and I was like, hey, this Python thing is kind of cool. I should redo it in Rust. And this is how I got here. And, you know, what I had in Python was like an hour's work. It was on a plane, but it was enough to get me started. So, you know, I guess if you want to start a weird side project, if it's something you're really passionate about, find a simple thing that you can start as a first step, hack it out in a language you're confident with, and then jump into the deep end. Like, if your goal is to do it in Rust, hack out a proof of concept in Python, verify your understanding of the kind of problem space, and then just jump into Rust. Ultimately, it takes a lot of time. That's the other thing. I'm unemployed at the moment, so I have all the time in the world to spend on these weird projects and to just do whatever the hell I want. And I love it. That's really great for me. But there will come a time when I go back to work and I can't just stream random stuff like this for 2 hours in the middle of a Monday. All right. So, expected expression found this. Ah, yes. I have done something wrong. I did something else wrong as well. That does need a dollar sign. Okay. Let's do this here. Expected U32 found U16. Yes, that is correct. Well, what I can do, rather than putting, you know, as U32 here, which is doable but annoying, I can actually hide this. And I can say as U32, but I might need to wrap this in parentheses just to be safe. I'm not sure what the hygiene's like. Expected option U16 found integer. Yes. Result. Okay, or invalid read. Cool. Okay, that works now. That works now. And we can verify that the memory address is correct. Excellent. Excellent. So what was missing there was read to, I forgot, returns an option, an optional, like it may not be an actual thing. So we just need to wrap it up in an error and then return it out because we're in a result. Now, this macro won't work unless the function we're in returns a result, and that is quiet and that is hard to know. So this is kind of bad macro hygiene, but I know how this is going to be used in tests, and it's test code, so I'm a bit happier to have a janky API for it. Dinkelman says, they're not a huge fan of IDEs yourself. The JetBrains suite has a lot of opinionated backends that aren't configurable. Without Clippy or TSC yelling at you for doing dumb stuff, you're like a fish out of water. Honestly, like, if you go through my code here with a fine-toothed comb, you're going to find a lot of weird jank. I am just very confident about it, and I'm just plowing through. At a certain point, I run Clippy, I run, you know, I should actually probably run a formatter. I'm a bit overdue, but I'll do that before I commit. But Clippy will be like, hey, what the hell are you doing? And I'm like, oh, of course. But you have to have the code there for Clippy to be angry at you, which is good. You know, if you want to get better at writing code without an LSP, without TSC or something yelling at you, the only way to do it is to start writing without it. I know that if I stop doing this, I'm going to lose the ability. It's like navigating with Google Maps, right? If you navigate everywhere with Google Maps, you will lose the ability to navigate without Google Maps. So you've got to keep it up. You've got to keep doing it. It's like that. It's like feeling your way around in the dark. I've been doing it a lot for 8 years now, so I'm just kind of good at it. Test. What else are we going to do? Let's test pop. Yeah, you know, like anything in life, there's no magic. It's always just you need to do it more than the other people around you if you want to be better at it. Unfortunately, that's the sad reality. You know, lots of people try and tell me that I'm a really good programmer, and I just ask them, I'm like, you know, have you written as much code as me, right? If you had written as much code as me, you might be a better programmer than me. No one can ever tell me that they've sat down and written, not no one, but you know, the kind of people that tell me they think I'm a really good programmer, they can never tell me that they sat down and wrote code every day for like 6 years to be a really good programmer, you know? There's no magic bullet. In a way, you know, I had a lot of bad health, and I still do, and that means I have a lot of days where I feel kind of crappy and I'm indoors. Yesterday, I felt like shit. I wrote a bunch of code because I'm good at it, and I don't have to, you know, expend a lot of physical energy to do it. So in a way, my circumstances have made me a very good programmer, but I'll take it. I'll take it every single time. You know, you gotta make something of your hand. Okay. So, I want to write an address. I want to write a value to memory. Let's just push then pop. That's fine, honestly. Let's 512. So let's go A. Let's push A to the stack, and then we're gonna pop. But we're gonna pop it to B. VM, we're gonna take register B, and we're gonna assert that it's 521. Excellent. And I should probably actually push more things to the stack, just to verify this is actually good. Okay, so now this is -246. -2 should be 1, -4 should be 222. Yeah. Yeah, this is good. You know, it's hard. I'm sorry to hear you have health issues as well. You won't learn how to play guitar if it sits next to your desk. This is my life right now. I bought a guitar and I can't play it because I just haven't spent the time. Really, really kind of devastating. It's okay. I'm doing lots of other music. I'm distracted by other things. 333, and we'll do B is gonna be 111. Whoa, 111. We'll push A. We'll push B. And then we're going to do a stack op, we're going to do a swap. Now, if we look at the virtual machine, what happens to this register? This register is ignored when we do a swap, which is great. So we can actually just pass in like 0. Excellent. So then we want to assert that. Okay, so we want to assert that the one on top of the stack should be 333, and the one below that should be 111. Excellent. So swap works like we expect. Like, I'm pretty confident this stuff will all work as I expect. I've written a lot of stacks in my life. What else do we have? Oh, peak. Oh, actually, okay, so what I should do with pop, I should push 2 things to the stack and then pop 1 off. Because then I'll get to be more confident. So push this, push that, pop that, but then also assert that the other thing is the top of the stack, right? So, what did I say? 188. Yeah, cool. How about some that you're not creative at all? Playing your favorite songs is a solid outlet. Like you're creative, right? If you're doing it, you're creative. There's no magic, right? The difference between someone who's creative and someone that isn't is just doing the thing. It's just rocking up. It's awesome that you're playing guitar. I love it. It's so good when you have that kind of outlet in your life. You know, I'm not doing it super seriously these days. I was kind of thinking about trying to get into it again a bit. I might see if there are any bands around that are keen to pick up like a flute player or a saxophone player, if I can network a bit before I go back to work. Just have some fun with that. But I don't think it's really going anywhere, sadly. But yeah, it's good. Because I studied classical flute at uni many years ago. I didn't finish the degree, but I started it. Okay, so let me copy what I've got for push. So testing peak is going to be the same as testing pop, except, and let's just change this to, we expect everything to be the same, but the results should be subtly different because the head of the stack will be different. The head of the stack will be the same as the thing that we popped off. 5, 2, 1. Right, because peak is just the same as pop, we just don't update the stack pointer. Beautiful. Okay, but you know, I studied classical flute, and so like I've still got some good flute chops. I'd love to do some more modern stuff with it because classical is so impenetrable. Okay. There's a lot of copy paste here, but that's okay for tests. I've had this argument with people many times. But you know, tests, if you're going to duplicate code, do it in your test cases. Awesome. Okay, so the top of the stack should be 88, and the second thing in the stack should be 88. And let's do it one more time for good measure. The third thing in the stack should also be 88. Now I think we have rotate, right? Rotate's the most involved operation that we have. This is going to be... We're going to need to push 3 things onto the stack, then they're going to get shuffled around. So it's not even hard. We just need to actually put that much data in the stack. Let's do 1, 1, and then push it, and then 2, 2, and then push it, and then 3, 3, and then push it. Sorry, did I call this rotate or did I call it rot? I called it rotate. So it's kind of funny, right? I wrote out swap. Oops. I wrote out rotate, but I did not write out duplicate. That's good. That's good. I love my consistency. Okay. Push rotate. So now we want to say, so the thing on, so 3, 2, 1, we should get 2, 1, 3. I think that's how rotate works. Yeah, beautiful. Okay, we also have 2 arithmetic operations on the stack, which is kind of fun, because I just thought that would be efficient. We can add stuff together on the stack. So let's do a number that's good. Let's do 40, and let's do 60. And let's see if the top of the stack is 100. And then let's also do the same thing. Let's subtract 20 and see if the result, oops, is 20. Okay, so something does go wrong here. Attempt to subtract with overflow because the top thing gets subtracted from the bottom thing. So actually, this is 20. if we put the correct bracket in. Nice. Okay, so that's our whole stack instruction set, you know, kind of sub instruction, right? We match an op inside an op that does extra things. These could all be in separate instructions, by the way, but it just kind of made sense for me here to encode them all together. Okay. The other thing is load stack offset, by the way, which again, I'm not sure is particularly useful. I guess it's okay, right? Because this is basically like indexing an array. I guess the name is bad. Oops. Oh, I always, by accident, somehow press the key combination that puts my keyboard into flash mode, which is not good. I just have to replug it. Test load offset. Okay, so because when you have, for example, the base pointer in a function call, well, if you dedicate a whole register to that, I'm going to, and then maybe regret it. But if you have a base pointer, or just in general, it's useful to say load this index of the stack, you know, like stack n, or more generally load the nth 16-bit word from an array of 16-bit words, I guess. So in this case, this is going to be an assert reg, but this is good. So we want to put 111. Okay. So then we want to say load stack offset. We want target SP word. So we want to put into C the stack offset of 2, 0, 1, and this should be VMC, I think. Okay, hold on. Let me do this better. 2, 0, 1, 2, 0, 1. Okay, that is interesting. Your keyboard binds function Z plus C to Bluetooth modes. Yeah, I had a keyboard that did that. It was with function QWERT, which is a little bit harder to hit. Like just the proximity of function and Z, I guess, makes that annoying. Function A is supposed to pause your mic. If you press that too fast, any other keybind it reboots. Do you mean reboots the keyboard or reboots your computer? Because those are, oh boy, different magnitudes of severity. Okay, so I guess the thing is that this gives you some garbage, right? You never want to load, or do you? Okay, this is interesting. If this is a general array operation, then yeah, sometimes you might want the 0th index, obviously. Actually, no, because you can get the 0th index. You can always say load, right? You can always just load an address. This would be like saying load. Whoa. Okay, hold on. I'm getting a call. I'm gonna have to jump off, but this has been fun. Let me just quickly finish this. I'll debate the finer details of this later. Excellent. But with that, I think we can safely tick off the stack. We're done. And with that, I will probably go and finish off the rest of the tests and come back and do interesting stuff again next stream. So we're making good progress. Thank you so much, Dinkelman, for hanging around and chatting. Thanks everyone who swung by. I will catch you next time.